Hello and welcome everyone. We are going to speak about the last lipoprotein, the HDL, and we are going to simplify it. The HDL lipoprotein, the high density lipoprotein, is really hard and complicated. The metabolism of this lipoprotein consists of several steps. We are going to start with the formation of this lipoprotein. So, HDL is formed in the intestine and the liver. Different from other lipoprotein, it is not formed as a spherical shape, it is formed as disc shape, called nascent HDL, containing only ApoA and free cholesterol and phospholipids. The hepatic HDL contain additional apoproteins, the ApoC and ApoE. These apoproteins have important function as we explained in the previous video. So the newly and recently formed disc-shaped HDL passes to the blood, where it has a very important functions to perform. So I had read several books about the HDL metabolism, and I have noted there is a little different scenarios between different books, different sources that explain HDL metabolism. First of all, the hepatic HDL passes the ApoC and ApoE to the intestinal HDL. As you note, I put a reference on the right bottom to even more make simplifying to the events, because it will be complicated as you will see. So, and I made a crime scene consisting of the liver, the peripheral tissue, and the foam cells, in addition to the lipoproteins. So there will be multiple events that will happen simultaneously, all at the same time. So I made 2 copies of HDL in a hope to simplify these events. First of all, the ABCA1. This protein helps the transfer of cholesterol from the tissues or the foam cells into the HDL. So it simply allows the passage of cholesterol to the HDL. At the same time, the other lipoproteins, chylomicron and VLDL, pass their triglyceride to the peripheral tissue, and then they give back the apoproteins, the C and E, back to the nascent HDL, still called nascent. The nascent HDL is now flooded with the free cholesterol it has received from other tissues. And now comes the function of the LCAT, the lecithin cholesterol acetyltransferase enzyme, which function easily to esterified the free cholesterol, converting it into esterified cholesterol. The esterified cholesterol is more hydrophobic than free cholesterol and tends to move away from the aqueous solution, and therefore, as more cholesterol esterified, the nascent HDL was once disc, now it is a spherical shape. And this spherical shaped HDL is called HDL3. It has esterified cholesterol, which exchanges with the remnant lipoprotein by CETP, explained in the previous video, and the triglyceride from remnant lipoprotein passes to the HDL3, converting it into HDL2, and the IDL is converted to LDL as explained in the previous video. As you can see, there are 2 copies of HDL2, each of which has different pathways. First one, the SRB1, and the second one is the hepatic lipase. The SRB1 allows the intake of HDL2. SRB1 is a scavenger receptor class B type 1. This receptor allows the intake of the HDL2 into the liver, while hepatic lipase allow the intake of only triglyceride, leaving an empty HDL3, not 2, to get back into the blood. Now we have a focus on the reverse cholesterol transport. We will continue explanation from where we stopped. The empty that is left to go back to the blood, HDL3, return to the blood and takes more cholesterol, free cholesterol from other tissue. The LCAT converted into esterified cholesterol and allows the HDL now to get back again to the liver or to steroidogenic tissues to intake this cholesterol, and either in the liver to for excretion or to make hormones in the steroidogenic tissues. Now the HDL return to be empty and return to the blood, which go back to take more free cholesterol from peripheral tissue. This is why it's called good cholesterol, because good lipoprotein, because it takes and allow to get rid of cholesterol that has built up in the peripheral tissues. So the HDL3 also can return and exchange triglyceride in exchange for esterified cholesterol, and convert it to HDL2, where it go back to the liver for the delivery of cholesterol and triglyceride and the lipoprotein, other lipoproteins. And so the HDL3 now return in a new cycle to the blood to receive free cholesterol. So consider you are fasting, and this is why fasting is good to lower the cholesterol level. Consider you're fasting, so the HDL, the cholesterol received from peripheral tissue, it will directly return either to steroidogenic tissue or to the liver for excretion, and so on, and the cycle keeps repeating itself. So as long as you are fasting, the blood cholesterol will keep lowering thanks to HDL. And thank you for watching.